Okay, 13 is a bit of a tricky one. So let's talk it through. First thing we want to do is we want to state the restrictions. The restrictions are what? Carolyn. 5m squared not allowed to equal 0.
Then divided by 5.
Yeah.
So m squared is not allowed to equal 0. And then the square root of m, or of m squared is m.
Yeah. So then you squareable, and so m's not allowed to equal 0. This is going to be, can we see already that this is going to be the same restriction here and here?
Yeah.
If you can see that already, you don't need to do them all again. So there's my restriction. Now we actually want to go through and solve this thing. First thing I want to do is what? See, Caroline will do it. Caroline, one sec. I want to see if anyone else can do it. What else, or what's the first step? Yeah, tell me.
Is it like if you combine the denominator, or not combine them, it's going to be like 1 times m times 5m squared?
Oh, so we want to get rid of the denominators. Yeah, we want to get rid of the denominators. And to do that, we want to multiply by the lowest common denominator. So what you were suggesting was I multiply by, so I'm going to multiply here by m times 5m times, so you're suggesting I just multiply by each of the denominators because there was an expression there. This one is a little bit tricky because yes, we do kind of want to do that. But how are these three denominators all related to each other? Carolyn.
5m squared is the same as 5m times m.
This guy right here, 5m squared, is the same as this guy times this guy. So the lowest common denominator of these three is actually just going to be this guy times this guy. So I don't need to also multiply by this, because then I'm double multiplying by it, and it's actually going to make our life a little bit more difficult later on. So what we want to do, what you were suggesting, when we've got full expressions in the denominator, that's going to be the easiest way to do it. When there's not a full expression, you want to be careful to see if I take what my lowest common denominator actually is. In this case, this guy times this guy is going to give me this guy. So I'm only going to multiply by these two. So I'm going to do the same thing here, multiply by m times 5m, multiply here by m times 5m. Here, my m's are going to cancel, leaving me with 1 times 5m, which is just going to be 5m. Plus, now I've got 5m squared on the bottom, and I've got m times 5m on the top. M times 5m is 5m squared, so these two are going to cancel with my denominator, leaving me with 2. And that's going to equal what? It's going to equal m, yeah. So I got 5m plus 2 equals m. The last thing I'm going to do then is, well, not the last thing, a couple more steps here. What am I going to do? Yeah, I can subtract 2 on both sides, absolutely. What else am I going to do in that same step? Oh, I mean, we could do it in the same step. I'm not going to add m. I'm going to subtract m on both sides because this m here is positive, and I want to move it over. So I'm going to subtract m there, subtract m there. There, my 2's are going to cancel. So I'm going to get 4m equals negative 2. Divide by 4, divide by 4. M is going to equal negative 1 over 2. Is negative 1 over 2 the same thing as 0? No, so we're good. And we're done. Comments, questions, concerns about what I've just done? Okay. Anything else? Sorry? Carmen? This guy right here? Okay. What's the restriction? Or just tell me what you got for the restriction. What's the restriction? We didn't do the restriction? Did we attempt the question? Okay, so what did you do the restriction? Okay, so what'd you get? That's not a restriction. So for the restrictions, you said each denominator cannot equal 0. So I'd have 2x cannot equal 0. X cannot equal 0. Do I care about the 4? No, because there's no variable there. So what is the restriction? No, what? What is my Did we attempt this question? Did we try this question? It doesn't sound like we did. Okay, so what do we do? So Carmen, then what do we do for the restriction? We've been doing this for, I gave you like 1,000 questions on restrictions. What do we do for the restriction? 2x what? X is not allowed to equal 0. Did we do this? Did you write this down?
Yeah.
Okay, then why didn't you say it? So 2x is not allowed to equal 0. So then what are we going to do?
I don't know.
We don't know. Okay. Carolyn, what are we going to do? 2x is not allowed to equal 0. Divide by 2, divide by 2, x is not allowed to equal 0. I don't know how many, like we've done this a lot. This is like the simplest part of the question. We take the denominators, we set them up, they cannot equal 0, and then we just solve for it. I wonder how much effective practicing we've been doing, if Carolyn's the only one that can do that at this point. Is this restriction going to be any different? No. So I don't need to do it again. So now I want to get rid of my denominators. What is the lowest common denominator of 4, 2x, and x? Carolyn. It's going to be 4x. Because the lowest common denominator of 4 and 2 is going to be? And the lowest common denominator of x is going to be? X. So the lowest common denominator of all of that is just going to be 4x. So I'm just going to multiply through by 4x. So my x's are going to cancel there. If I have 4x divided by 2x, what's that going to leave me with? It's going to leave me with 2. So this is where we have to use all the skills we practiced in the exponent section. And then 4x divided by 4 is 1 what? X. Thank you. So that's going to leave me with 1 times x, which is x, plus 1 times 2, which is 2, and 6 times 4, which is 24. Subtract 2, x equals 22. Anything else anyone wants to see out of these questions? Preferably questions that you've attempted and got stuck on. I would love it for you guys to progress as far as you can into a question. Don't just look at it and stare at it and say, I don't know, and then stop. Because, again, the first step is always the same. Find the restrictions. Second step is always the same. Multiply by the lowest common denominator. If you can't find the lowest common denominator, if that's what's messing you up, fine. Then stop at that point. But at least recognize that that is the next step. I need to get rid of these denominators by multiplying by the lowest common denominator. So that when you say, I want to see question number whatever, you can say, this is where I am. Attempt the questions. Anything else? I didn't give you these answers. A, E, C, and F. What did we get? Carolyn, what did you get for A? Sorry, I mean just like for a final answer. What was your final answer for A? 5 equals x? Okay, maybe I misheard you. 5 equals x. Okay. Anybody else get 5 equals x? And that was not very many of you, but some of you. This is good. C, what do we get? X equals? Rebecca? Ooh, we got an undefined and we got a -1.
The restriction is -1.
The restriction is also -1. So if your x equals is equal to your restriction, then your final answer needs to be undefined. So you were almost there, Rebecca. You did. Getting -1 means you did all the math correctly. Just that last step. Love it. X is undefined. Love it. E, what do we get? Carolyn. Can someone verify? X equals -1. Aminat got it? Okay. And F. Aminat.
X equals 1/4.
Can someone verify? Carolyn got it too? Okay. So there they are. We've gotta practice this stuff. I know I don't check homework, but you're gonna get a quiz, you're gonna get a test, all this kind of stuff. The reckoning will come. Questions, comments, concerns on any of these four? Okay. Then we are going to start looking at, the next probably week and a half is going to be all just word problems. Analyzing word problems, which is everyone's favorite part of math because it requires some reading and a little bit of thinking. And we don't like to read in math, and sometimes thinking in math is hard because I just want an algorithm to follow. And I just want to do things, but now we have to think about what we're doing. And in my experience, we don't like this. So, before we do that, we're going to launch into a small section here on what has been titled Changing the Subject. I'll see if I can get through 2 lessons today. We're going to look at using formulas and changing the subject. I don't like this title. What I'm going to call this instead is isolating for different variables, which is a skill that you're going to need forever in math. So basically, this is exactly the same as what we've done already, except instead of having one variable that we're trying to solve for, there are several variables, and we can solve for any of them. In some cases, we're going to solve for all of them and just, see what happens. So in this expression right here, I've got x equals 2y. This expression is already solved for what variable? It's already solved for x. X is what's isolated here. X equals 2y. But what does y equal? Carolyn? Yeah, y equals x over 2. Because I wanted to isolate now for y, because I've got 2 times y. To get y by itself, I'm just going to have to divide by 2, right? Divide by 2, and I'm going to get y equals x over 2. Or x over 2 equals y. That's it. And we're just going to do that with increasingly complicated expressions. Here we go. I've got this guy. X plus 4 over y equals 3. And when it says here, it says to solve the following equations for the variables indicated. I want to isolate this thing for x, and I want to isolate this thing for y. It doesn't matter which one of these you do first. So, let's just pick someone at random. Armand, which variable would you prefer we solve for first? Sure, let's do it. Armand, I would like you to pick someone to try and isolate for x. No, Carolyn wants it. You could that's the easy pick. Carolyn, solve this thing for x. What do you do? Take a look at what we've got here. Right, so the first step is exactly the same as it's always been. And I want to get rid of that denominator. So I'm going to multiply, because the denominator is under everything, I'm going to multiply y on both sides. It's going to cancel my y's, leaving me with what, Carolyn?
X plus y equals 3y. And then subtract 4.
Leaving me with?
X equals 3y minus 1.
Love it. Done. Someone else. Be brave. We'll start again. X plus 4 over y equals 3. And now I want to solve this thing for y instead. I'm going to.
Multiply each side by 1.
First step is exactly the same. On the left-hand side, my y's are going to cancel. And I'm going to be left with x plus 4 equals 3y.
Divide both sides by 3.
This time, instead, we are going to divide both sides by 3. Leaving me with y equals what?
X plus 4 over 3.
Have we solved for y?
Yeah.
You betcha, we're done. Not too bad, right? Maybe it's because it's Monday morning, but you guys are not like overabundance in your responses to me this morning. Questions about what Aminette and Carolyn did? Okay. Let's look at question number 2. Got a different expression now. I've got 2a plus 4 over x minus 1 equals 5. So it's a little bit more involved. I want to solve this thing for a, and I want to solve this thing for x. So I'm going to do it in blue, and we're going to do it in brown. I'm going to draw the line down the middle of the page again. Which one do you want to solve for first? A. Just because it's listed first? Okay, that's nice and easy. So who wants to be brave and solve for A? Gavin. All of a sudden Armand's in charge. I love it. Oh, it was Akam? Akam said it? Akam's in charge now? Well, Gavin, how about you try one and Akam tries the other? I think you do. It's the same stuff we've been doing. Okay, Akam, you're going first. Okay, so we're going to get rid of that denominator. We're going to multiply both sides by x minus 1. Okay, which one are you solving for, A or x? Okay. So I'm going to rewrite the question here. X minus 1 equals 5. And you said multiply both sides by the denominator. Cool, I love that. So that's going to cancel my denominators on the left, leaving me with 2a plus 4 equals 5 bracket x minus 1. Okay, what now?
Minus 4. Or distribute
We could do both. Would you like me to do both? Which one do you want me to do first? Distribute the 5. Okay, so I'm going to distribute the 5 in. And you know what the heck? Let's also subtract 4. So I'm going to get 2a equals, and now I'm going to get 5 times x is 5x. 5 times negative 1 is minus 5 minus 4. So then I'm going to go back up here, and I'm going to get 2a equals 5x minus 9. Bless you. Last step. Yeah. Oh, sorry? Divide both sides by 2. A equals 5x minus 9 over 2. Love it. Questions, comments, concerns? Okay. Gavin, do you feel any better about the other one, or do you want to hand it off to someone else? Sorry? You think Armand could do it? There were some hands over here. Armand, you want to try it? I'll give you a hint. The first bunch of steps are exactly the same as what Acom did. Okay. Exactly the same question. We're just solving for x. No, we haven't finished this one yet. Sorry, I didn't quite hear you. Multiply both sides by? Okay, cool. So I want to get rid of the denominator. So I'm going to multiply both sides by the denominator. So in this case, the denominator is x minus 1. We're going to multiply by that on both sides. Cool, love it. That's going to be gone there. So I'm going to get 2a plus 4 equals 5 bracket x minus 1. Because I'm multiplying this whole denominator by 5. Now what? Absolutely. Good choice, sir. I'm going to get 2a plus 4 equals 5x minus 5. This time we didn't also subtract by 4y. Anybody? Guten Tag. Always. You always. But okay. We didn't subtract by 4 this time because we're not isolating for a. We're isolating for x. And so to bring it over to this side would be counterproductive. We want to keep everything on the left. So what do I do? What's my next step here to get x by itself? We're going to add 5. Love it. Because 5 was negative, we're going to add it over both sides. Boom. Cancels there. You're leaving me with 2a plus 9. Love it. Equals 5x. Last step, sir. Love it. X equals 2a plus 9 over 5. Fantastic. Questions about what the gentleman in the back corner did? I'm not totally sure which one of them did it. It was Armand by himself? Love it. Because Armand did it perfectly. Love it. Last one, number 3. There is someone on this side of the classroom who's been itching to help out all the way. They just don't want to start it. But I think if this person was brave, they could do it handily. No, I don't think you are. I think you can do it. I want you to try it, Rhea. So you knew exactly who it was too. I love it. So this is the last one example we're going to do here. I've got a equals pi r squared. This is the, yeah, go for it. You can take what you need. Yeah, it's unlocked. And I want to solve this thing for r. This is the formula for what? Yes, Rebecca. Area of circle. So this is the formula for the area of a circle. So if I wanted to find the radius of the circle, I could take this formula and I could manipulate it. I could solve for r. So what's the first thing I want to do, Rhea? I want to get r by itself. By divide by pi. Yes. Yes. Because I've got pi times r squared here, yeah? And I want to get r by itself. So I'm going to divide by pi. I love it. Pi is just a number. We're allowed to divide by it. So I'm going to get a over pi equals r squared. This one's a little trickier now because this is an operation we have looked at, but not in the context of this chapter, really. I want to get r by itself, and right now I have r squared. How do you undo a squared? No. You square root. So I want to square root both sides. Yeah. So I'm going to get the square root of a over pi equals, what is the square root of r squared? That's just going to be r. Right? Because squaring and square rooting are opposite operations. When you do both of them to the same thing, they cancel. So I'm just going to be left with r here. Does anyone need proof that the square root of r squared is r? Because I could show you a different way too. By converting the square root into a fractional exponent. Oh, maybe we should definitely do that then. If that scares us, we definitely, because that test was a while ago and we need those skills. So the square root is what as an exponent? It's 1/2, right? Whatever number goes right here becomes the denominator of our exponent, and when there is no number, in a root, the number is 2. So this is the same thing as r squared to the 1/2. Yes? We see how that happened? 2 of you are nodding. 3 of you are nodding. 1 of you is bouncing. I love it. What do I do with these two exponents? I multiply them. What's 2 times 1/2? 1. So that's going to give me r to the 1. What is r to the 1? It's just r. See, that wasn't so bad. All things that you should be fairly comfortable with at this point. Okay, and there was no other variable to solve for here because we'd already solved for a, and pi is not a variable. Yes? Yes, but what would that do? That would put an r in the denominator here. Then you'd have a over pi times r equals r, and I want to get r by itself. So I've actually just split up the r's. I've made it worse. That's why you don't want to do that. Okay, so flip the page. Here is what we're going to do. There are a bunch of questions here. There are 15 of them. There are 2 mistakes on this thing that I just found. Number 3, I don't want you to solve for b squared. I want you to solve for b. Scribble out that 2 up there. That's question number 3. The other mistake is number 14, because that's not even b squared. That's just a comma. It's p equals a over a plus b, comma, solve for b squared. I don't want you to solve for b squared. I want you to solve for b. And that's the only one. I want you to flip the page again, and you'll see the answers to the questions I just assigned right here, except there are 2 mistakes in the answer. Question number, 3 isn't done yet. So we're gonna you have to finish 3. Where are the 2 mistakes? There are, maybe there's only one other mistake. It is 15. In 15, that should not be b squared. It should just be b. Oh, hold on. Let's solve for a. Yeah, no. There is no b squared, so there's no squared there, and there's no squared there. We can get rid of those. I'm pretty sure those are the only mistakes in the thing. 3 is not done, and 15 is incorrect. So, I want you to try these. We'll see how it goes. I can come around and assist you as needed on your market set giver.